by the coordinator. Any single subordinate can vote no, and that's it. Okay? And every message reflects a decision that is by the sender, meaning the coordinator. In the first case, it's a message, it's asking the sites to prepare. And in the second case, it's the information about the commit. And basically, the commit protocol records for a transaction contain the transaction ID, but on behalf of the subordinates, they also have to record the coordinator ID. And as I mentioned, the coordinator's rollback and commit record includes the IDs of all the subordinate sites. So it's not only the transaction, but also every single subordinate has to be recorded so that it can roll back. And now let's talk about what happens when things fail. Things never fail except when they do. Nothing can go wrong. Original rest was world movie. Nothing can go wrong except it does. Basically, suppose that there's a failure. And basically, let's say it's a failure of the coordinator. The coordinator failed. If you have a commit or log or rollback log message for a transaction, but you don't have an end record, this is a little bit weird because it was a distributed transaction. You have to go ahead and you have to do what's required to redo or undo T. Now, if it's a subordinate, then you have the commit or rollback and the thing failed and you don't have the end record. You just do what you would do if it was just a one-site thing. So if you have a subordinate and the subordinate comes back and sees that there's a commit or a rollback, but there isn't an end record, it'll just do it again and it's unimportant and that's going to be okay. But if you have the coordinator, it's got obligations to all its subordinates. All the kids got to be told what to do. And so it will go ahead and it will send appropriately either the commit or the rollback until it receives acts from all of them, at which point, give me the acts, the acts, the acts. At that point, it can write the end record, which says everything is done. Question?
So I'm a little confused about, is the subordinates every single site there is? Because
no,
before
only the ones that are involved in the transaction. The coordinator knows which sites are involved in the in the transaction because the application is being run at the coordinator and other sites are being introduced into that way. It's a little bit complicated because sometimes a subordinate site may send it on to the another subordinate site, but that has to end up getting tracked. And that ends up being tracked. Subordinate introduces another subordinates, then there ends up being a tree that's involved in that. That's a little more complicated. But basically, we'll assume here that the coordinator knows about all the subordinates that are involved. Not all the sites have to be involved. There could be 20 sites and the transaction might involve only 3. Okay? Only the ones that are involved. Now, suppose that a subordinate comes back. Let me go a little more and then I'll take the next question. Suppose that the subordinate recovers from failure and it sees that there is a prepare record. It doesn't get to unilaterally decide anymore. As soon as it wrote the prepared record, it delegated to the coordinator the decision about what to do about the transaction. It cannot decide. It's got to hear from Big Brother back there, the coordinator, to figure out what's going on, the boss. If there's a prepare, but there isn't a commit or rollback record. So that means you've got to go ahead and ask. So you send a message to the coordinator which says, please tell me. I can't release my locks. I can't decide what to do for this transaction until I hear from you. So basically, if you hear, then you'll do what the coordinator said, and you'll write and you'll write the commit or rollback record, whatever the thing says, and you'll do the redo or undo depending on what's involved, and then you'll write an end record. So the end record basically in both cases says, I have no further obligations on this transaction. Not to ask about it, not to tell anybody about it. And what do you do if you recover and you don't have a prepare record? You'll roll back the transaction. You will just go ahead and you'll roll back the transaction. So again, the coordinator sends a prepare message to all the subordinates, and the coordinates can veto. But if they say yes, they write a prepare record first, and then they send back to the coordinator, The coordinator, if he hears yeses back from all the subordinates, will write the commit record, including information about the transaction ID and the subordinates. It will then have obligations to make sure that all the subordinates hear about the transaction, whether or not it fails or the subordinates fail. That obligation is there and must be fulfilled. If a subordinate fails and comes back, if there's a prepare record, it's got to ask the coordinator what to do. Interesting protocol. Suppose that you have a coordinator for a transaction and it fails, and then you've got subordinates. And they're waiting to hear what's going on, and they don't know, and the coordinator failed, and they're stuck. They don't know what to do, so the transaction is blocked. Even if all the transactions know all about each other, they can't decide without the coordinator. Well, if one of the subordinates voted no, then that's it. But even if all of them voted yes, the coordinator might not have committed. So basically, if you have a situation in which a remote site doesn't respond during the commit protocol, then if the transaction has not been committed and a subordinate doesn't reply, the coordinator can just roll the thing back. So another reason to decide to roll back is I'm waiting too long, this guy hasn't responded, I'll just roll it back. The coordinator, until the commit record is written, the coordinator gets to decide on its own. It can decide just to roll away the transaction. But basically, if you have a situation in which you have a current site is a subordinate and it hasn't voted yes, it can also blow away the transaction at any time. But again, if a current site is subordinate and has voted yes, it's prepared, it doesn't have a choice, it's blocked. Blocking is a terrible thing. So notice that the acknowledge messages are used to allow the coordinator to say, I don't have to remember this transaction anymore. I have to keep track in memory that I have an obligation on this transaction. And I have to keep trying to send the subordinates as they come up periodically or when I get a message, the subordinate get back. So the coordinator has to keep the transaction in its transaction table. And that could take a really long time for the subordinate to come back. Okay? If the coordinator fails after sending the prepare message, but before writing the commit rollback log, well, when it comes back, like any other thing, if it was in the middle, if it was an active transaction, when it comes back, it rolls back the transaction, not a problem. It has the right to roll back the transaction at any time if it hasn't written the commit record, okay? Another point, suppose that you have a coordinate that doesn't make any changes. It doesn't have to be involved. It doesn't have any locks, okay? So basically, its commit or rollback status is irrelevant. You actually, when I said that you have to take a vote only among the subordinates that are involved, you don't have to involve a subordinate who is only reading. It doesn't have any rights to do. It doesn't have to write anything in the law. Okay, now we're going to talk about what were classically called presumed commit and presumed abort protocols. And the one that we're going to talk about is presumed abort. Both of those were defined. Again, this is a paper by Mohan and Lindsay on this. And if you prefer, I'll say presumed rollback, but classically it's called presumed abort. Coordinators have to keep track of information about all transactions in the transaction table, and that can end up taking a long time to deal with. In the presumed abort / presumed rollback protocol, it doesn't have to keep track of transactions that are rolled back. So it sent prepare messages to all its coordinates, to all its subordinates, it sent prepare messages to all the subordinates. For whatever reason, because the subordinate voted no, or because the coordinator decided, what the heck, things are taking too long, we're gonna roll this back. It might have decided to roll back the transaction. And here's the fun part. I told you before that it has to keep the transaction in its transaction table forever until it's told all subordinates the status of the transaction. There's an important optimization here. And the optimization is what we call the Sopranos forget about it optimization of presumed abort. I grew up in New York, not New Jersey, but I got lots of relatives in New Jersey. The forget about it kind of optimization is if the transaction rolls back, I don't have to keep the information about the transaction around anymore. I do if it committed, but not if it rolled back. Well, how is that? There might be a subordinate who questions me and says, I want to know whether this transaction committed or rolled back. Well, if I have information in my transaction table that says that it committed, then I'll say. But I don't bother keeping information in my transaction table about a transaction that rolled back. So if I look in my transaction table and there ain't nothing there for this transaction because I forgot about it, I presume that it's an abort. That's why it's called presumed abort. I will only forget about transactions if they rolled back. If they committed, I will not forget about them until I have taken care of all my obligations. That's why this is called presumed rollback or presumed abort. If I don't know anything about the transactions anymore, then I will basically be able to say the transaction rolled back. And that's the way everything ends up working on this. Okay? So basically, when subordinates, well, so that's the way things end up working. There, as I mentioned, when you have subordinates that are readers, there's a third message instead of yes or no that a subordinate can send back. Instead of saying yes or no, it can say I'm a reader, which basically says you don't have to tell me nothing because I'm okay. I don't have any log records. I don't have to hear any more about this. So there's a third response you can get to a prepare message, which is I don't care. I don't know. I don't care. And so the readers can end up being and if all the subordinates are readers, then you don't need the second phase of the transaction. If the coordinator site is the only place where it's right, that ends up being okay. Questions? Because we're about to go into summary. So again, subordinate gets told by the coordinator to prepare. It will respond yes, no, or possibly reader. Once it says yes, which means it's written in prepare record, it does not have the right to unilaterally abort. The coordinator has an obligation to tell everybody that the transaction committed. If it committed, writes the commit record first. It has all the subordinates in it. If it rolled back, it doesn't have to keep track of the transaction because if it gets asked, it said, oh, that transaction, I don't know about it, it must have rolled back. But if it's committed, it will not write the end record for the transaction until all the subordinates have been informed. That's two-phase commit. And it guarantees that everything works, and we'll talk about a couple of variations of it in a second. So again, parallel databases are designed for scalable performance. Relational operators work very well. It's as if there's a single database to be able to work. Distributed database, and there may be parallelism across the distributed databases as well. You have multiple sites that may have autonomy. You have to deal with separate administration, perhaps by different departments in a company, or maybe across transactions that are done across different companies. By the way, nobody does transactions across different companies. They do workflows. You want to have autonomy. So you have to be able to deal with that. And why do you end up splitting things into multiple pieces? Size matters. I mean, you could do it because there are different parts of the company that want to do things on their own, but it could also mean that you want to split it up into different pieces because scale up doesn't necessarily work well. So you want to try to scale out kind of approach of dealing it and have multiple but there are other disadvantages of having multiple transactions and all the stuff that we had in the two-phase commit that we just described. Again, do not confuse two-phase locking and two-phase commit. Is that okay with everybody, I hope? I won't make all my jokes about two-phase. I did that last time. Okay, let's see. I'm going in the wrong direction here. Now we have a coda, last slide in this lecture. So basically, what does a subordinate do if it's blocked? And it's blocked for a long time. Remember, the show must go on. The business has to run. The coordinator is down. The subordinate can't hear from the coordinator. And I'll give you several different answers. One approach is called, heuristic decision making, heuristic commit. which basically is, I need to keep going. I'm just gonna make a decision as to what the transaction did. I'll hear later from the coordinator and I'll deal with the consequences if I'm wrong. That was an easy thing to implement, and of course it could screw things up pretty badly if your decisions were wrong, because it's not just the wrong decision, it's the cascading other wrong decisions that may be based on that wrong decision. Then there was something which was a thesis by the fellow by the name of Dale Skeen at Berkeley for something called three-phase commit. The general idea in that approach is the coordinator gets himself a buddy, different buddies for different coordinators. And before the coordinator decides to tell people about the commit, it tells its buddy. And so if the coordinator is down, the buddy knows. And so if you can't talk to the coordinator because you're blocked, you'll be able to ask the buddy. So that's another approach that ends up being used to do with this. Tandem did something that is a more complicated variation with process pairs. Then there's a notion that Lamport and Gray did of something called Paxos commit. I will mention in passing that there was 20 years before a paper that was written on something called Byzantine commit that was written by Mohan, Ray Strong, and myself. And amusingly, when I told Gray about this existing, he actually added something to his Paxos commit paper that said, apparently there was 20 years ago a Byzantine commit paper that also did this, but we have a different fault model when we save one message. He was right. But it shows you how old things, end up showing up in various ways. You may know about the Paxos algorithm. If you don't, I'm not going to go through it. But it basically ends up being something where you have a community that keeps track of what the situation is on the commit, so that if the coordinator fails, you end up finding what the decision is based on the community of people that are involved. And there can be different communities that exist for different coordinators. So there's a logical coordinator, but it's really a committee that's involved in doing it. And that way, a single coordinator failure won't deal with that. And then there's Amazon Aurora. And again, this is a reference to actually an earlier Aurora paper than the one that I mentioned. And here's the general idea of how things end up working in Aurora. It's kind of amazing. You want to be able to deal with the possibility of things where you end up having a failure of what Amazon calls an availability zone. There are different availability zones that have independent failure models. So what you will do is you will end up having 6 sites for the replication, 2 sites each in 3 availability zones, 2 times 3. And the way that it's set up is you could lose an availability zone and even one of the nodes in one of the other availability zones, and you'll still be able to do work. Now, it means that you end up having 6 copies, but networks are fast these days. You pay the price for it. There are games that are played so that the price or the cost of having to deal with the replication is cheaper. And you don't have to, again, you can play R plus W greater than N games, variations of that with the availability zones. You don't actually wait until everybody hears about it before you can commit. And there are things split up into different partitions, and there's great recovery stuff that's worked in it with sizes of things that are on the order of about 10 meg for the way that you do your partitioning into pieces. But here's the thing. What happens if a site goes down? Aurora, by the way, is Amazon's implementation of MySQL. They also have one for PostgreSQL, where they just put a different storage engine underneath MySQL. MySQL is designed to be able to deal with multiple storage engines underneath it, including the transaction processing. So they do their own version of this. And transparent to a MySQL application, they have Aurora underneath it instead. So they're campaigning to try to get everybody who's doing MySQL to run on top of Aurora instead. Now, why is it worth it to have all these copies? Because it's extra storage, it's extra CPU, it's having to deal with the, it's not a distributed commit, it's basically a R plus W greater than N variation of things, including playing with logging and lots of interesting things about where you do the commit. Read the paper. Discuss it with me if you want to. It's a very interesting paper, much easier to read than the later one. Why is it worth it? Well, if a customer has a failure where the site goes down, that's a big black eye for Amazon with the customer and possibly going public. So they don't want it to fail. They don't want their own stuff to fail. They don't want the customers to fail. That's important. But there's another point. I already mentioned to you that Jim Gray did the survey of the bugs at Tandem and found out that, I forget whether it was a quarter or a half, but a pretty high percentage of bugs were due to operators. If you have a situation where somebody goes down and you have to figure out, particularly with distributed commit, you have to figure out about how to proceed going forward. Heuristic commit is going to make mistakes. Having site down for a while is going to be really bad. Having operator and managers from the customer to deal with the problem, ugly, expensive, not friendly to the customer, customers are not going to be very happy about it. Customers want it to just work. They got a lot of hardware, they got a lot of memory, they got a lot of networks, they got a lot of cores. They pay the price of having multiple replicas, having the latency issues involved in replicating across multiple replicas. For a near guarantee, sure, two availability zones could fail simultaneously. It doesn't really happen. But they pay the cost to make sure that everything always works. That's a big deal. That's a really, really big deal for the customers. And emphasis. If something fails, remember I talked about MTBF and MTTR, mean time between failures and mean time to. They will, if a piece of something goes down, they will repair it very, very, very quickly. They will detect it quickly, they will repair it quickly. Which basically says the possibility of there being multiple simultaneous failures is extremely low. Sure, you could have some misconfiguration thing in an availability zone where somebody screwed up how the availability zone is configured and you can no longer get to it. You still have two availability zones. Everything can still go on. And you'll bring that availability zone back up, you hope quickly. So things go wrong, but everything still works. With very, very, very high probability. Knowing that the database is universally available all the time is a really big deal because operators and administrators are expensive, get things wrong, and telling people that it just works is wonderful advertising, particularly if it's true. I told you the Tandem we called our systems nonstop TM, and inside Tandem we referred to them as seldom stop because we got the bug reports when things went wrong. They were really good, but not perfect. Having an ability, paying a hardware price and even a little bit of a latency price for having everything work all the time is a really, really, really big deal and a trade-off that seems to be working for a lot of people. Comments or questions? We are now done. I'm not going to start on the next lecture. We are now done with the part of the course that will be on the final. I'll talk about spatial database next time. I doubt that I will get to the LSM tree lecture. I will post, I think I already posted the spatial database. I will also post the LSM tree thing. We already talked about LSM trees a little, but this expands on it. But I'll talk about the spatial database relatively quickly next time. Again, emphasis, it will not be on the final. If you have questions, please talk to me during my office hour today or post things on Piazza. And again, there will be a a lab section tomorrow if you want to ask questions about, on Friday, if you want to ask questions about any parts of the course. We will be posting our own Lab 4 solution on Friday as usual. And I guess as I go out, I will mention, this course is a fair amount of work. It's a bloody capstone course. It's supposed to be a fair amount of work. For those of you who made it through, I hope that you've learned a lot. I hope that this will be stuff that will allow you to do well when you're interviewing for jobs, as well when you're doing anything that ends up relating to database. And again, I will emphasize, and again, there is a lecture on Friday, that we're touching just the top of the iceberg. The amount of stuff in database that goes beyond in both theory and practice, what we've talked about in terms of this internal, what goes on. And I talked about the Wizard of Oz and the guy behind the curtain of how this worked. You've learned a lot about what's going on. There's a huge amount more, some of which I've alluded to in the codas, some of which I couldn't get near But if you're excited about any of this stuff and wanna talk to me more, let me know.